Actually, it started, the searching technologies in ChemAxon started with JChem base. I guess you are familiar with it, but I probably have to mention that this guy who is sitting here, he was the guy who was coded the first part of the code. And yeah, we can still see some parts of the code which is tagged with his name. And since then, we have to acknowledge that it is improved a lot. And yes, it's improved. And let's say it became an industry standard nowadays. And based on this JChem-based engine, we have created many years ago the JChem Oracle Cartridge, which is integrated in many tools, like John also mentioned that they are integrated in it, but also in many tools. And yeah, this JChem Oracle Cartridge is used in large pharma companies very often. And you know that this was in 20 years ago approximately, and let's say 3 years ago, the team decided that, the search engine team decided, the JChem team decided that it is very nice, we can provide new features, but what about if we come out a totally new search engine, we can call it a next generation search engine, which has some really cool features, but it's reusing the search engine which is implemented in the JChem base. So we wanted to keep the very useful and well-known chemical knowledge of the search engine, but we wanted to improve somewhere and provide new features. I will talk about that. These new features we implemented in the Postgres cartridge, and that was the first product having this new engine as a backend. And it was approximately 2.5 or 3 years ago. And now we arrived to the point that this week, on Monday, the JChem team released JChem Choral, the new JChem Oracle cartridge. And the feature, which I was not showing so far, is, for example, the hit as you draw feature. I think the video can show you that what is it about. So you are drawing your structure, and while you are drawing your structure, the first here is first 5, but maybe you can even choose to show the first 100 hits is appearing instantaneously, we can say, as a hit. And what you can recognize that it is a different behavior. It is really an interactive view, interactive mode, because it's not the way that you draw your query structure and you hit the search button and you draw your query structure and you hit the search button again, but it is something you are speaking with the database, and the database is providing back the hits. Technically, this means that we implemented this fast searches with hit limit. That means that if you are drawing your benzene structure, that was the first one, and I don't know, it's 1.6 million a size of 1.6 million structures in the database, then we will not give you back 1.5 million structures, because probably you are not interested on that. Just the first, let's say, 100. And the other feature, which is heavily needed in this case, that the hits are ordered according to the similarity to the query structure. You don't want to see arbitrary or very huge structures if you are searching for a very simple structure. Okay, the next feature is fast joint and combined search. And actually, I don't go into the details. What does it mean, fast? Because Ákos Tarcsay, he's sitting over there. Ákos Tarcsay will speak about that. What does it mean for us that it is a fast? And because he's quite a polite guy, he's comparing the JChem Oracle cartridge and the JChem-based speed with the newest development, with the Choral and probably with the JChem Postgres cartridge speed. The other features which we are shooting for is to handle large databases. So Ákos will also show that, yeah, in 5 years ago or 10 years ago, it was enough if we were speaking about molecular databases in 1 million, 2 million, 5 million structures. But nowadays, in the last 5 years, we see that this is not enough anymore. You know that, for example, the e-molecules database, the number of molecules in the e-molecules database is increased heavily from, I don't know, few million structures. Now it's 17 million structures, or a little bit even more. You may heard about even bigger databases, probably also the enamine, which is 720 million structures. So that's what we are shooting for. And for the Choral, which is a cartridge, Ákos will speak about only for 40 million structures database there. On the other hand, I would like to emphasize that Zsuzsa, who is sitting here, she will have an hands-on training just, I don't know, in the next session, probably, hands-on training, where he will show you the tips and tricks how to access this functionality from the Oracle cartridge. And the last bit about Choral is the Amazon RDS. How many of you are familiar with the relation data store feature of, or relation data store service of Amazon? One. Okay, then probably it's only interesting for you that Choral is running on an RDS. For the others, maybe it's important that the RDS system is managed and keep up with in Oracle, so it's a cost-effective solution. Okay, about the architecture, it's very similar to the previous one, to the JChem, to the JChem Oracle cartridge. So the Choral is similarly running a separate service and communicating with the Oracle database. Because I'm running out of time, I don't want to speak about more about this one. And I go for the JChem MicroServices. We already had, ChemAxon or currently we have, a monolithic JChem web services. And what we wanted to change is exactly the monolithic service into a modular one, a microservice architecture. We wanted to make it modular, scalable, easily manageable, and highly available service. And if we have that, these features, okay, then we can say that this solution is a cloud-ready solution. So what we have as a module so far, the first module was released, the DB search module was released end of last year. And since then, and also the IO and structure manipulation module was released the end of last year. Since then, we have created the chemical property calculation module and the Marcus stateless modules. And what we are trying, I have to mention that from these modules, we can say that some of them are cloud-ready, but we are working on the DB search module to be totally cloud-ready, which means highly available and also to, let's say, work in a distributed environment. These are the new modules which we will work on. We will come up with a search stateless module where you can compare just two molecules, reactor module, structure checker, and probably it's interesting for you, and maybe I will ask that how many of you are interested in to have a web service interface on the top of cartridge. How many of you are interested in such modules? None. Okay, that means that probably this is not so important. We can even skip it from the product line or from the plans. Project Haystack is trying to handle such a situation which we have seen in many of the large pharma environment, that they have very nice database, very well-structured, standardized database silos where, for example, the corporate data is staying. On the other hand, this is not the case for everywhere because they have also silos where they have, let's say, external databases which were uploaded once, but it's not maintained. And our idea for the solution is to able to provide a solution which is handling all of this, but not in separate silos, but in one accessible points where you can search for internal and external data and multi-millions of structures with a very simple interface. Actually, Norbert Schosch, he's standing over there, he will speak about more detail tomorrow. Finally, the graph database. Okay, finally the graph database. How many of you are familiar with the graph database? Of course, Tom Sawyer perspectives, guys. Okay, so if you are not familiar, you just need to think about that. We have nodes on the database, and we have connections, relations between the nodes in the database. And what is very important in the graph database, then you can add extra nodes and extra relations easily to the database without corrupting the whole database, which means that you don't have to create a new table or add an additional column to the table if you want to add just one information, one line to the database. It has a very nice query language, Cypher query in Neo4j database. And the visualization is also important here because yesterday we have been a pub. Yes, we are sometimes appear in a pub. And that's what we have seen here. So for example, when somebody was interested in some, I don't know, some ales here, then they can easily choose another ale which was very similar to the ale that he or she is like. Or if somebody is fan of IPA, then he can go to, I don't know, this Stranting ale, which is again very similar to the thing that he already likes. So it's not just the database itself, but also the visualization, which is very useful. Why graph databases? Because we are focusing on the relationships and not the nodes itself. So if you have a very complex database, what you have here is the ChemBL database with many tables. These byte things are all different tables, and you are searching relations between or among these tables. Then you will get on a relational database a very huge joint statement, which is huge and slow. And it's not because of the problem is not that it is huge, the statement itself, but it is very slow. It is much faster in a graph database. And also, if you are trying to find the shortest path in a graph database, because you have a structure which is active on site 1, and if you have another structure which is active on site 2, and you want to find a structure which is, let's say, have some activity on the site 1 and site 2 as well, then the shortest path can give you a very good impression that what is the structure you want to deal with or you want to search or go forward on it. And this is a very simple Cypher query which is returning this structure. On the other hand, you can do it in the relational database as well, but it is much more complex. This is how you would do it in a relational database context. What we did and what ChemAxon provided in the graph databases is that we created a chemical search on that. So you can create a table or let's say a set where you can put nodes in this set. And if you have this set and if you put nodes in this set, then you can do similarity and substructure search on this set. And probably finally, my talk is ending with the Triumvirate, that Neo4j is providing us the chemical backend, or the backend, the graph database. ChemAxon is providing the chemical knowledge on this graph database. And Tom Sawyer Perspective is providing the visualization. And the next talk is going to be from Brandon, who will speak about the Sanofi use case, where all of these three providers are used.
Real-time structure search, I think that's already can be done even with current cartridge, right? Because you can ask it to return, you don't need to ask it to return the whole complete hit list, right? You can just ask it to return 10, right? Then you can get this real-time feed.
I'm happy to hear this answer. However, I have to say that if you have, let's say, 10 million structure, then you will get the hits in arbitrary order. And if you get back, I mean, just take the simple benzene example. You are searching for a benzene ring. Of course, you would never ever do that, but you start drawing your structure. Then, and you get back, I don't know, a very complex structures where you don't even see, or you can hardly recognize that, okay, yeah, there is a benzene ring somewhere in this structure. So probably I would have to emphasize here, it's not just that you get back the first 100 quickly, but also the fact that these structures are the more relevant to your query. And on the other hand, the other thing is that for a large, so the current Oracle cartridge is not, I have to acknowledge it cannot deal with 100 million structures. It's not.
So the other question is, I'm just trying to understand why Neo4j, the graphical search, has offered a benefit, because the current cartridge, it does the fingerprint screening, right? And then it runs a graph comparison in Java, right? So I imagine you just implement that code within Neo4j. The performance will be the same, I would imagine.
Probably it was not, I was not totally clear, and sorry if it's my fault, but it has no connection to the Neo4j itself. So actually the new search engine which was created by the team, which is capable to this functionality, let's say that. So if I go back to my slides, oh, I cannot, then the Choral, the JChem Choral, which is a cartridge itself, is capable to do this. So it has no connection to the graph database. The graph database has different advantage, and it's not about the hit as you do. Yeah, it's not about the hit as you do feature. And also I should emphasize that the web services, the new microservice architecture, is also having this feature, this hit as you do feature. So the Postgres cartridge, the Choral, JChem Choral, the microservice architecture, these are all having these features. They are very fast, and they are having this hit as you draw feature. Is it clear now, or?
And the performance mostly improves through the software or by throwing a cluster of servers?
No. It's just it's not a cluster of servers, unfortunately, yet.